software tutorial for the optimization and creation of pneumatic circuits. Today I'll guide you through the main basics of the software and as well show you how to use various catalogs and how to design the schemes. So here we have control panel where you can load new project, save project, and so on. Here you have the scale of your grid. You also can use without the grid. And here you can change also the grid step. On the right hand side, we have input parameters that are general for the full system. For example, the temperature of the air, the ambient temperature, the critical pressure ratio of ideal nozzle. Here is the standard one as a default parameter. Here is a very important aspect. This is the cost of compressed air. So you can change to different values. And information about the operational data of system, how many hours per day it works and days per year to calculate compressed air energy cost per year or per unit that you would like to have here. So here we have our libraries. So there are various libraries integrated, and you can each type of component has behind the certain type of the calculation, but those all the parameters are real, and we see now how to use this in the scheme. So let's start. We always start with the source. The source, it is the simplified model. It can be the air reservoir or it can be compressor room. So the source basically represents the certain pressure, flow rate, and also shows you the cost of the system that is designed after the source. After the source, we'll have, for example, a pipe. So I put here tube. To connect it, we choose the output and connect it here. So in the program, it's always green. It is the input, red it is the output, and those two dots always has to be connected. After the pipe, I would like to put here the valve. So for example, we can put the 3-2 valve. So here we have a general libraries for Artemis. Some just example few components. So we connect it here once again. And after this, I want to have another tube. To move the component, you just choose everything and then you can just drag it here. For components, you can use plus to copy it and minus to delete it. You also can rotate, and you also can mirror the component in case you want to do this. So let's go back here, and the pipe also shows you the direction here, and again output with input. And after this tube, I want to have the blowing tube. So let's go to the component that we call blowing tube. We put it here and we connect them. So let's have a look at each component, and here we can have the green is always input, manual input. Black, it's everything that comes from the catalog. So we need to click on each parameter and have an input there. But if you press calculate, the program will automatically ask you to parameterize each component. For this, you need to choose tube, put here diameter. So the program shows you with this red frame which parameter we're now parameterizing, which component we are parameterizing. And now it is asking me this tube, and now it's asking me this tube. Let's do this. And now we need to put the input pressure here now in bar, and the program calculates automatically the full network of components. So let's have a look. First of all, the tube. When we have the warning sign, it means that there is something wrong with the design. When we have this sign, it means that we have an opportunity to replace this component by more efficient component. Let's look at the pipes. But before we go in the warning design, I want to show you the list that goes optimization. Here, before starting the calculation, I chose the optimization criteria. So the one of the main parameters to optimize our system is the allowable pressure drop. I put here that my allowable pressure drop, I don't want to have more than 0.3 bar. You can change and put 0.5 bar, calculate it. And the system shows you, the program shows you what are the components have a pressure drop higher than half a bar. So this is basically those two pipes. Let's have a look. Yes, delta P here, pressure drop 0.7. Here it is 0.6. It also in blue you'll see all the calculated parameters. Red shows you the recommendation. It means here we have a very small pipe, and green shows the possibility for optimization. If you press at the source, you see here the compressed air cost, as well as the flow, as well as the pressure in bar, required pressure to operate this pipe. So right now the system costs 600 euros. Let's take a look on what we can change. So I just copy the full diagram here, and I can drag here, make it look nicer, because I want to have a comparison of two systems, optimized and not optimized. I press on calculate, and let's start optimizing this. So first of all, I would like to change the tubing here, and the program tells me that I can have two other tubes, and I would like to change. So the first, it's always the best recommendation. I can put just change, and now I have here another tube. So let's also see if we can change this one. Change. Now the cost is already lower because we need the lower pressure here. It's 520 euros. This one was 609. However, I still can change and replace this pipe. For this, let's have another comparison. Calculate. And we see that program proposes other analog blowing guns. Here we calculate the blowing force, and according to this blowing force, we can choose various blowing guns. Right now we have blowing guns from Sylvant, and it proposes 66 blowing guns. Of course, it is many of them, and we can filter according to our wishes. First of all, we have two kinds of filters. First filter is a fixed. It's basically a filter of label of the nozzle technology. This is mostly constrains the construction type of the blowing gun. And then we have range. Range, it is the ranged by the parameters in the catalog, like replacement of the open pipe, blowing force again, pressure. I would recommend to start with the pressure, because this is the main requirement that we can really get wrong with the wrong pressure level. we remember that here we have a pressure of 5 bar of supply pressure, and we can change here to 5 bar. So this would be the first filter. So now I have fewer blowing guns, and from those blowing guns I already can choose what I actually want. But we also can do an advanced filter here, and let's say, for example, I want to have the Laval nozzle technology. I have now fewer parameters here. And then the last filter I can choose, that could be, for example, material. And now I have 3 blowing guns. As I recommended you before, the first one is usually the closest one. So, and here you can see the pressure, the blowing force 4 newtons. We have 3.7. Perfect. We change it. And now we have the blowing gun here. It also calculates the flow rate. You also can check in the catalog, and the cost is lower. However, it's not dramatically lower because we have here a high pressure drop, because we need to have another blowing gun with a higher mass flow requirement. So what it tells us to change, the diameter of the tube here, diameter of the tube also has to be bigger here, and the valve also has to be changed because it has a very high delta P, the very high pressure drop. So what I would recommend? I would recommend first start with the pipe. We can, if we don't have it in the catalog, we can just change it manually. And with the same principle, we connect to our blowing gun. We calculate it. We parameterize the diameter of the pipe and put it, for example, 10. And, sorry, it had to be not 10, it had to be 12, for example. And we see, so before changing completely all the components, we need to calculate always step by step, because the previous pressure drop has an impact on the next one. So now we have the lower pressure drop. However, we still can change it. Maybe we can play also with the length. And right now, here, for example, the pressure drop is already lower. The same principle we can also do with the pipe diameter here. And as you can see, the costs are already lower. So use the libraries that we have here to change various components, and enjoy using the first version of the software with integrated libraries provided by Directin together with Artema.